Okay, so let's have a look at the 2020 Higher Level Leaving Cert Maths Paper 2, question 3. So we have a flagpole GH, so it's from here up to here. It's vertical and the ground is inclined at an angle of 5 degrees. So the ground goes up along here and the flagpole starts here at G. The angles of elevation from E and F to the top of the pole are 35 and 52 degrees respectively. So we have an angle here of 35 and an angle here of 52. The distance from E to F along the incline is 6 meters. So we have 6 meters along here. How far is F from the base of the pole G along the incline? So we've got to find this distance here. Give your answer correct to 2 decimal places. Okay, so the way I'm going to approach this is I'm just going to write in a few angles here that may or may not be useful. Let's see, we have 52 degrees here. So I'm going to write this angle in, I'm going to write this angle in. I can write in this angle here and this one here as well. So let's just write in these angles. We may or may not use them, but let's see what we can do anyway. We have this angle here is going to be 128 degrees because this is a straight angle along here. So we can work that out as 128. If that's 128 degrees, this must be 17 degrees up here. We have this right angle triangle down here at the bottom. So we have 5 degrees in here, which means we have 90 degrees here. So this angle here must be 85 degrees. So this angle here is 85 degrees. If that's 85 degrees, we can work out this angle here as 95 degrees. And finally then we can work out this one because we have these two angles here. So that angle up there will turn out to be 33 degrees. So there are all the angles that I can work out. From that then I need this side down here from F to G. Let's call it X. So I think what I can do is use the sine rule to work out this side here from this triangle. And then once I have that, I can use the sine rule from this triangle here to work out what X is. So let's do that. I'm going to work out this side here first using the sine rule. So I'm going to say the sine of 17 degrees divided by 6. So that's this angle here and this side here. And that's going to be equal to the sine of 35 degrees divided by the distance from F to H. Okay, so let's work through this. So that will give us the distance from F to H times the sine of 17 degrees is equal to 6 times sine 35 degrees. Just cross multiplied there. So that would give us the distance from F to H is equal to 6 sine 35 degrees divided by the sine of 17 degrees. And then finally, when you do that, you can do all of this on the right hand side on your calculator. You get the distance from F to H as 11.77083337. Okay, so I have this distance here now. I have this distance here. So let me just write that in. This is one that I've just calculated here. So it's 11.77083337. So now that I have that, I can work out X. So I'm going to take the sine of 95 over this here is equal to the sine of 33 over X. So let's work through that. So I have the sine of 95 degrees divided by 11.77083337, and that's equal to the sine of 33 divided by X. So again, I can just cross multiply here. And that finally just gives me x is equal to all of this here, 11.77083337 sine 33 all over the sine of 95. And that will give you x is equal to 6.43534 and so on. Now we were asked to give our answer to 2 decimal places, so that will give us finally then x is equal to 6.44 meters. And that's it for this part of the question. So let's move on to part B. So I have part B down here. So in the diagram, the large circle S, so this big circle is S here, has center O, and the small circle C has center D. The circle C touches the circle S at the point C, so we have a point C out here. OA and OB are tangents, so this is a tangent here, and the radius of C is OR, so this is our radius here, or here even, or here. The ratio of the area of S to the area of C is K to 1, find the value of K. Okay, so what I'm going to do here is just look at this angle here. This angle here is 60 degrees. So this angle here within this triangle here, this right angle triangle, must be 30 degrees. So this is 30 degrees in here. Now I can write down then that the sine of the angle COA, which is 30 degrees, is equal to also OR over the distance OD. So the sine of this angle 30 degrees here is equal to OR over OD. Okay, so if I work that out, I get sine of 30 degrees is a half. Multiply that by OD, and that gives me OR. So what have I found out from this? I found out that the distance OR here is half of OD. It's half of this distance here. Now remember, this is OR here, so this is OR here as well. And we've just found out that OR is half of OD. This is OR here. So therefore, this must be OR here as well. The distance from here to here must also be OR. The distance from O to D will be double OR. OR is half of OD. Okay, so from this we can see that the radius of S is going to be 3R. So the radius of S is going to be 3R. That's the distance from here to here. So that we can use when we're working out our ratios. So let's do that. We have the area, we want the area of S is to the area of C. Now the area of S is going to be pi r squared. Well, in fact it's going to be pi times the radius of S, which is 3r, and we've got to square that. The radius of C is just going to be pi r squared. So if we do both sides, or do the left hand side anyway, we've got pi times 9r squared. On the right hand side we've got pi r squared. Now we've got a pi here and we've got a pi here, we've got an r squared here, we've got an r squared here. So what we're left with is 9 is to 1. That just means that k then must be equal to 9. And that's it for this question.